Hello, Stat 200, and welcome to Lesson 5. This is the first of 2 lessons on hypothesis testing. This week, in the Lock 5 textbook, you're going to read sections 4.1, 4.2, and 4.3. If you've never taken a statistics course before, you're probably wondering, what is hypothesis testing? Hypothesis testing is a method for testing the likelihood that an observed sample came from a population with a given parameter. Like the confidence intervals that you worked with last week, hypothesis testing is an inferential procedure. We're using data from a sample to make a conclusion about a population. These are the key topics that you're going to see this week: writing hypotheses, constructing randomization distributions, identifying p-values, and using p-values to make a decision. Let's start by writing hypotheses. The first step in conducting a hypothesis test is to write your hypotheses. There are going to be 2 hypotheses: the null hypothesis and the alternative hypothesis. The null hypothesis is denoted as H sub 0. The alternative hypothesis is H sub A. In the null hypothesis, the population parameter is equal to the hypothesized value. In the alternative hypothesis, the population parameter is greater than, less than, or different from the hypothesized value. To write your hypotheses, you'll need 3 pieces of information. First, the parameter that's being tested. For example, a population mean or a population proportion. Second, the direction. The direction in your research question is going to determine the direction in your alternative hypothesis. This will be greater than, less than, or not equal to. And finally, the hypothesized value. Let's look at a few examples. Here's a research question. Is the mean age of all world campus students greater than 32? The parameter that we're going to be testing is the mean. The direction is going to be a right tail test, and the hypothesized value is 32. In other words, is the population mean greater than 32? Remember, the null hypothesis always contains an equality, and the alternative hypothesis can never contain an equality. Our null hypothesis here would be that mu equals 32. Our alternative hypothesis is that mu is greater than 32. Here's another example. Is the average height of a female high school senior different from 64 inches? We're going to be testing the average, so the parameter that we're interested in is mu. We're not given a direction in this example. We just want to know if the mean is different from 64 inches. This is a 2-tailed test. Our hypothesized value is 64. We want to know if mu is not equal to 64. So our null hypothesis is that mu equals 64, and our alternative hypothesis is that mu does not equal 64. Now, let's look at randomization distributions. When constructing a randomization distribution, we shift the observed sample so that the sample statistic is equal to the value in the null hypothesis. Then, we take random samples with replacement. This is similar to bootstrapping. The only difference is that before we take those samples with replacement, we first shift the observed sample so that the sample statistic is equal to the value in the null hypothesis. This distribution can be used to determine the p-value. To determine the p-value, find the area in the randomization distribution that is more extreme than the observed sample statistic in the direction of the alternative hypothesis. There are a number of examples in your online notes this week that walk you through this procedure. We can use that p-value then to make a decision. A small p-value means that it is unlikely that a population with a hypothesized parameter produced the observed sample. Traditionally, a p-value that is less than or equal to 0.05 is said to be statistically significant. So if your p-value is less than 0.05, you would reject the null hypothesis. Your results would be said to be statistically significant. This means that your results are in favor of the alternative hypothesis, and there is evidence of a difference in the population. If your p-value is greater than 0.05, then you fail to reject the null hypothesis. Your results are not statistically significant, and there is not evidence of a difference in the population. Note that when we fail to reject the null hypothesis, this does not mean that the null hypothesis is true. It only means that we do not have enough evidence to reject it. There are many examples in your online notes this week that walk through the 5 steps of conducting a randomization hypothesis test. As always, if you have any questions this week, please post them to the Lesson 5 discussion board on Canvas.